All right, here we go. Number 1 on your homework, there's only 3 questions, so we're going to do all 3 of them. Make sure you set up the process in the right way. So it says use the intermediate value theorem to show that there's a solution. Okay, solution means that the function equals 0. That's what the solution is. Okay? Or it crosses the x-axis. That would be an x-intercept. Okay, for the given equation, I'm just going to write f of x equals x to the 5th minus, okay, assuming this is your f of x, right, it's equal to 0. It wants to know if there is a solution between x equals 2 and x equals 3. So the first thing I have to say is f of x is continuous. It's a polynomial. It's continuous. The second thing I have to do is compare the y coordinates. Okay, so that might take a little bit of work here. F of 2 equals 32 minus 32 minus 2 minus 3. So equals negative 5. F of 3 equals 243 minus 162. Positive number, right? It's positive 75. Thank you. Okay, 75. Okay, so I actually haven't compared the coordinates yet. So f of 2 is less than f of c is less than f of 3. Now I put f of c. C is like the point in question. This value is actually 0. So negative 5 less than 0 less than 75. Whichever order you have to write that inequality in, write it in order. The negative number is less than the positive number. It doesn't matter which x coordinate you're using, just make sure the y values are in order. Okay, the third thing you have to do, make sure that the c value is actually between the endpoints. 2 is less than c. Okay, and conclusion. In order to say yes, there is a solution, this inequality actually has to work, and so does this one. Okay, that means you can say yes, f of c equals 0 with c between 2 and 3. The answer is yes. Why did you say yes? Because this inequality works, and so does this one. It's the y one that you really have to look at. Okay? The x is, it's going to be between 2 and 3. Yes, there's a c value such that there is a solution as long as c is between 2 and 3. Okay, so let's do number 2. Show that there is a number c, okay, such that f of c equals 1. Step 1. F of x is continuous. Step 2. Compare the y values. I don't see any endpoints. Okay, so I didn't give you the endpoints, which means you're considering from negative infinity to positive infinity. However, maybe just check a few values. Okay, now you're looking for this. So as I'm looking to set up my y value inequality, I'm just going to make a table of value of a few points to see if I can find something that's going to surround 1. Okay, I'm going to start by plugging in 0 because that's an easy number to plug in. Then I'm going to try 1, and I'm going to see what happens. I don't have the endpoints. I'm looking for the endpoints. Okay. 1 minus 3 plus 6. 7, 3. Okay, and I happen to find them pretty quickly. If I were to say positive infinity, this would be positive infinity because of the end behavior. If I said negative infinity, that would be positive infinity because of the end behavior. So I just started at 0. And I would just keep moving out. If this number ended up being negative, I would have tried the other side. I would have tried -1 until I found something. Notice you're trying to surround the y value of +1. That's where I'm going to look because that surrounds the y value in question. Okay, so now I'm actually going to write my inequality. Yeah. Can I not add? Yes. Thanks. Still positive, so at least we're there. Okay, 4. Okay, write your y inequality. F of 0 is less than f of c is less than f of 1. Okay, 0 is less than 1 is less than 4. Okay, that is a true inequality. You're trying to make these inequalities true. If they're false, if I put a value of 5 here, you would be like, no, this point does not exist. Okay? Step 3, write your x inequalities. 0 is less than c is less than 1. Okay? Conclusion, yes, f of c can equal 1. F of c can equal 1. It can also equal 1/2 and 2 and 3 and 3.5. It can equal anything between the endpoints. With c between 0 and 1. Yes, this will happen. Why? Because of the intermediate value theorem. Yes.
When you say that c can equal anything in between the endpoints, you mean
between 0 and 1. That's why you write the x inequality also.
Okay, so it could be like 2 and 3.
So f of c can equal anything between the y endpoints, f of c. C has to be between the x's. So if you were to draw your picture, the x's would be, 0 and 1, and we would get 0 and 4. Okay? Make sure that you're comparing x's to x. C is an x coordinate. F of c is the y coordinate. Okay? All right. Prove that the function intersects the x-axis. Okay, that means f of x equals 0 on the interval 0 to 2. Okay, so we'll just call this A. F of x is continuous. 2. Well, compare the y coordinates. F of 0 equals 2. F of 2 equals 4 minus 8 plus 2. -2. Okay. This time I think I added correctly. Compare, right? This is the y part. We're still just finding the y values and comparing the y values. F of 2 is less than f of c is less than f of 0. Notice that the f of 2, that's because I need my inequality to be in order. Put the endpoints in order. Okay. Step 3, compare the x's. 0 is less than c is less than 2. Okay. These are the two things that we're looking at. We are trying to write those two inequalities. Are both those inequalities true? Yes. So, yes, f of c equals 0. C is between 0 and 2. This is only going to happen, yes, this will happen if C is between 0 and 2. Yes, Laura.
Sorry, did you plug in 0 to that equation to get?
Yes, yeah. I know that the x's cancel out. Here. No. Okay, here you go. 0 squared minus 4 times 0 plus 2.
Oh, okay. I was looking at
Yeah. Oh, no. There's 2 questions.
Oh, okay.
There's 2 questions. And then it said, can you say the same thing for this function? And so I would try it, right? Same setup. Yeah. Okay, so 1. F of x is not continuous at x equals 1. Therefore, no, I cannot say the same thing. Yeah, you put these endpoints in numerical order. So you should not say f of 0 and then f of 2 because that statement is not true. So you switch your endpoints to be in whichever order will make this inequality true. It doesn't matter which one's higher. You're still going to have to connect the dots. It doesn't matter which way you connect them. Okay, so that's your setup. You've got a few questions in your warm-up to try. See if that helps. Okay, verify the IVT and find C. It says find C, so there's actually 2 questions here. So the first thing I say is f of x is continuous. Second thing I do is compare the y's. So f of 0 is -1. F of 5 is 29. Okay, so f of 0 is less than f of c is less than f of 5. And then I'm actually going to write down the y coordinates. -1 less than the y coordinate in question, less than 29. Okay, so far it's working. F of x is continuous. The inequality is true. Third step, compare the x's. 0 is less than c is less than 5. Okay? Those things are true. F of x is continuous. I have y values that surround the one in question, and the x values surround the one in question. So yes, f of c equals 11. C is between 0 and 5. Okay, that was part 1. It actually said to find it. How would you find it? You would actually set it equal and solve. Oh, it's a -1. That was quick. Okay. -12. It actually happens to factor but the value they're looking for, 3, is between 0 and 5. They're only asking about this one because they wanted you to find C. So C is 3. That's the solution that fits into the inequalities that we wrote. Yes, there is a solution between 0 and 5. Then I found the solution between 0 and 5. Okay, number 2. F of x is continuous. Compare the y coordinates, okay? F of 0 is -4. F of 6 is 36, 38, 26. Okay, so write my inequalities. F of 0 is less than f of c is less than f of 6. Negative 4 less than 2 less than 26. Okay, there's my inequality. That's true. Okay, now for the x's. 0 is less than c is less than 6. Okay, yes, f of c equals 2. C is between 0 and 6. And then it said to find the value. 2 equals x squared minus x minus 4. X equals 3 and negative 2. However, C is the one between 0 and 6. So C is 3. All right. A little bit of context. Okay, the position is negative, I'm just going to write it over here, 4.9 t squared plus 396.9. Okay. Explain why there must be, did it say find the time? No, it just said explain why there must be a time. S of t is continuous. Okay. Is there a time with this height value in question? Okay. S of 1 equals, okay, I'll actually add that one up. Okay, S of 1 equals negative 4.91 squared plus 396.9. Oh, 392. Nope. Did I really get it?
Yeah. 392, yeah.
Okay, 392. 392. S of 2 equals, okay, plug in 2. 377.3. Okay, I can already tell the answer is yes, but I'm going to write down everything else I have to show. S of 1 is less than S of C is less than S of 2. 3, oh, nope, that's the wrong order. See that? Wrong order. Okay, you have to put it in numerical order. 377.3 is less than 382. That's the value in question. 392. Okay, this inequality is true. Okay, step 3. Compare the x's. 1 is less than c is less than 2. This is true. Answer, yes. S. Okay. S of t equals 382. T is between 1 and 2. I guess you could say C, but they're asking about T, so I changed it to T for the answer. Okay, last one. This one they gave me points. 1, 2, 3, negative 1. 1, 2, 3, 4, 5, 6. 1, 2, 3. No. Okay. Not necessarily. B doesn't have to be true, guys. Notice that that says f of x is between. The graph can certainly go outside of those values. The only ones you can guarantee is this one. F of c will equal 1. That's true. But so is D. There's actually two true answers. Right? Both of those statements are true.